So hi guys, mayong adlaw. Welcome to NatzMath TV. So in this video, I will be presenting to you on how to perform operations with rational algebraic expressions, specifically on addition and subtraction of rational algebraic expressions with the same denominators, or that is what we call similar fractions. We will have a separate video about performing addition and subtractions of rational algebraic expressions having different denominators because we will be using the LCD. So in this video, we will have similar fractions. So we will start a discussion after this intro. So how do we perform addition and subtractions of rational algebraic expression with similar denominators or the same denominators? So there's no problem in adding and subtracting rational algebraic expressions with the same denominator. What we need to do is just simply copy the common denominator. That's the most important part in addition and subtraction of rational algebraic expressions. So we will try these examples on the board. We are given 5 over x minus 2 plus 2 over x minus 2. So as you can see, we have here the first fraction and the second fraction. Denominators, x minus 2 and x minus 2. So what we need to do is just simply copy the denominator x minus 2 and perform the operation in the numerator. So we will have the common denominator is x minus 2, so we copy x minus 2. And we perform the operation in the numerator, that is 5 plus 2, which is equal to 7. So we have here 7 over x minus 2. So we try to check if this fraction 7 over x minus 2 can still be simplified. If not, then that is the final answer. So since 7 over x minus 2 is already in its simplest form, so this is now our final answer. Another, we are given x over 3 minus y over 3. So again, we have the common denominator, which is 3. So we simply copy the common denominator, which is 3. And we perform the operation in the numerator. So we have x minus y. So x minus y, since they are variables, so we cannot subtract x minus y, so we just simply copy the numerator x minus y. Then check if we can still reduce this one or simplify this one. And x minus y over 3 is already in its simplest form. So this is now our final answer. Next example. We are given the first fraction, 3a over ax plus ay, plus the second fraction, 2a over ax plus ay. So as you can see with the denominator, we have ax plus ay and ax plus ay. So again, as I've said, we copy the common denominator. In this case, we have ax plus ay. Then we perform the operation in the numerator, that is 3a plus 2a. Since they are like terms, because of a, we have here the a and a, they have the same variables. So what we need to do is just simply copy the variable and add the numerical coefficient. So we have here 3a plus 2a. The numerical coefficient here is 3 and the numerical coefficient here is 2. We add the numerical coefficient and we copy the common variable, which is a. So that is 3a plus 2a is equal to 5a. Next is, we need to simplify this fraction because we can still simplify this fraction. That's because of the denominator. In that denominator, we have ax plus ay. We have the common factor within the first term and the second term, which is a. We have a in the first term and a in the second term. So what we need to do is to factor out the common monomial factor a. So this becomes, we copy the numerator 5a over, we factor out the a in both of these terms. So we have a times. What remains for ax here is only the x. We copy the plus. And what remains the ay here is only the y, because we already have factored out the a. So if we are going to multiply a times x, that is ax, a times y, that is ay. The next is to cancel out the common factors in the numerator and denominator. Since the operation between 5 and a in the numerator is multiplication, and the operation between a and x plus y is also multiplication, so therefore we can cancel out the a. So we cancel out the a here and the a in the denominator. So the remaining fraction shall be 5 over, we have x plus y. So this is now our final answer. Now let's proceed to our next example. We have here x squared over x minus y minus y squared over x minus y. Again, we have here the same denominator, which is x minus y and x minus y. So we copy the common denominator, which is x minus y. Then afterwards, we subtract the numerator. We have x squared minus y squared. Since they are of different variables, so we just simply copy x squared minus y squared, since we cannot subtract x and y. Next is, we try to evaluate the fraction x squared minus y squared over x minus y. We simplify this fraction by factoring the numerator, x squared minus y squared. We can write this one as x minus y times x plus y. Then we copy the denominator, x minus y. Again, we cancel out the common factor in the numerator and the denominator. So we have x minus y in the numerator and x minus y in the denominator. So they are common, so we can cancel this out. What shall remain in the fraction shall be x plus y. This one. That is assumed to have denominator 1. We can write over 1, or we can have x plus y as our answer. Next example. So we have n plus 1 over n minus n plus 2 over n. So, as you can see, this is minus. You have to take note that this minus will determine the sign of the numerator in the second fraction. So what we need to do first is, of course, copy the common denominator, which is n. And afterwards, we copy the numerator of the first fraction, and that is n plus 1. Then, we copy the operation minus, this one, and we need to enclose our numerator in the second fraction with a parenthesis, because, as I've said, the minus will determine the sign of the terms in the second fraction. So we can have enclosed with a parenthesis, we have n plus 2. If minus, but if addition, there is no need for us to enclose with a parenthesis, because the sign plus will never change the sign of the terms. Okay, so we copy n plus 1, then n, then we have here the negative times positive, we have negative n, the negative times positive, we have negative 2. We copy over n. Afterwards, we perform now the operation. N minus n, so that is cancelled out because that is 0. N minus n is 0. 1 minus 2 is negative 1. So we can have negative 1 over n. So this is now our final answer. Next example. We have three fractions here. We have 10 over x minus 3 minus 2x plus 9 over x minus 3 plus 5x minus 7 over x minus 3. The same. We copy the common denominator, x minus 3. Then, we copy the first numerator of the first fraction, that is 10. We have the minus. Since this is minus, we enclose this one with a parenthesis, so that is 2x. plus 9, then we have the plus. Since this is plus, so no need for us to enclose with a parenthesis, that is 5x minus 7. Then, we distribute this sign to the terms inside the parenthesis. So, we copy 10, negative times 2x is negative 2x, negative times 9 is negative 9, then we copy plus 5x minus 7, and that's over x minus 3. Then afterwards, we combine like terms in the numerator. So we combine those variables and the constants. So we will start with the variables. So we have negative 2. So we have negative 2x plus 5x. So negative 2x plus 5x will give us positive 3x. Then we have the constant 10, 9, and 7. So that is 10 minus 9 is 1. Then positive 1 minus 7 is negative 6. That's over x minus 3. We can simplify this fraction by factoring the common monomial factor in the numerator, 3x minus 6, by factoring the common monomial factor, which is 3. So we factor out the 3 times we have x minus 2 over x minus 3. Now, after factoring, we have 3 times x minus 2 because 3 times x is 3x. 3 times negative 2 is negative 6. After factoring the numerator, we will try to check if there are factors in the numerator and the denominator which are similar. If there are similar factors, we can cancel out the factors. But in this case, since we do not have similar factors in the numerator and denominator, so consider this one as the final answer. Okay, that's it. I hope you have learned something from this video. I still have other videos here, so please watch these videos. So please do not forget to subscribe, like, and share to your friends. So for now, thank you and God bless.